We're finishing up the notes from Friday. So on Friday, we finished up with this one here. Now we're not going to have a problem exactly like this one here because we ended up getting a quadratic. And we won't have one of those on the homework or on the test. But we will have some that look like these and some of the other ones that we will cover today. And they're not as bad as the one we did or finished up with on Friday. Now when we look at these here, the theorem states that the tangent segment squared is equal to the length of the exterior secant times the whole length. So our tangent length here is x. So our tangent length squared, so for us here we would have x squared, is equal to the product of the exterior length, 12 times the entire segment, which would be 12 plus 15. So the square of the tangent is equal to the exterior secant times the entire secant length. Any questions on anything we have set up or kind of worked with so far on this here? So at this point here, we can do some simplification on the right-hand side. Because we can do 12 plus 15, and 12 plus 15 is 27. Because we can add 12 and 15 together. Now what can we do next? We can multiply 12 and 27. So we can pull out a calculator and do 12 times 27. We would get 324. So any questions on anything we've done thus far? Now, could we have really typed 12 parentheses, 12 plus 15 close parentheses into the calculator? Well, yes, the calculator could have calculated that all out. Because it's just straight numbers. All three of those are straight numbers. The calculator can do this. But we do need to make sure that we do put the parentheses in, that you don't do 12 times 12 plus 15, because it will not get you the correct answer. Because we have to add 12 and 15 first, because they are inside of parentheses. Now, what do we need to do next to get x by itself? We need to square root both sides. So the square root of x squared would give us x. Now we need to take the square root of 324, which would be actually plus or minus 18. And the reason we have the plus or minus is because negative 18 times negative 18 would be positive 324. Positive 18 times positive 18 would still be 324. We have the positive or negative case. So any questions on this here before we do the last part of this? So we're good getting to positive or negative 18? Now, when we look back at the problem, plugging in for x, well, x is the length of wx, which is what it's asking for, yes? So saying that this is 18, a distance of 18, that makes sense, yes? Because we can talk about distance as 18 units. Would I say that this distance is negative 18 units? Well, no, because if I ever talk about a distance from one point to the other, we're always talking in positive units. We will never have a negative distance when we're talking about just overall length. Because if we start plugging in or start using negatives for length, we just give it a direction. Because it could say north 18 feet or south 18 feet. We don't talk about distance in negative units. So we don't really say plus or minus 18. We just say that it is 18. Because we're talking about a distance, not a numerical number. Because if we're just talking about the square, what x squared, what value of x makes x squared equals 324, then it would be positive or negative 18. But because we're talking about an actual distance, it's just going to be positive. Questions on this here? Okay. Let's look at the next one here. Now we look at this one here. We do have a tangent and a secant. And the length of the tangent squared, so that would be x squared is equal to what? So it'd be 1 times 3 plus 1, because we want exterior times the whole length. So the exterior in this case is 1, and the whole length would be 3 plus 1. Well, 3 plus 1 is? Well, 1 times 4 is? Square root both sides. And we would get x is equal to plus or minus 2. But again, x is just a length. There's nothing being added or subtracted to it. Not being squared. So we just say x is equal to 2. And that is it on this here. Any questions on any of this here so far? Are you ready for the next one? Okay, so this is the next one we're going to look at. So when we look at this one here, we're going to do the exact same thing as what we just did on the last one. So the x, or the tangent length squared, is equal to the exterior times the whole length. So our tangent length this time would be 7 squared is equal to what? Well, the exterior part would be 5, and the whole length would be x plus 5, or we can do 5 plus x. The order really doesn't matter. Any questions on how we got this one set up? Okay, well now we can do some simplifying. This time here we actually don't have x squared. We have 7 squared. And what is 7 squared? 49 is equal to. Well, here we can distribute the 5 because we want to simplify this a little bit, so we will distribute the 5. And 5 times x would be 5x. 5 times 5 is going to be plus 25. What can we do next? We can subtract 25 from both sides because we're wanting to get x by itself, and the easiest step to do first is to subtract 25 from both sides. Because 25 minus 25 would be 0. And it'd leave us with 5x by itself on the right-hand side. 49 minus 25 is 24. Last but not least, we would divide both sides by 5. And if we type this into a calculator, 4 divided by 5 is 4.8. It doesn't divide into it evenly. Well, we would know for sure that it doesn't divide into it evenly because how do I know if a number is divisible by 5? It ends in a 0 or a 5. Any questions on any of this here? All right. We have 2 more problems left. Now this one here, I did change it because if we left it, because on your paper the 10 and the x are switched the other way around, yes? With the x being on the outside, what we would end up getting, it would have been 12 squared is equal to exterior times the entire length, which would have given us another quadratic. It would have given us another quadratic equation. Now, we're not going to delve too deeply into this at this point because I know that y'all have worked with factoring. In Algebra 1, y'all factored polynomial equations like the ones we had Friday. And then you've worked with solving, but you've never worked with factoring and solving at the same time. So instead of doing that problem, I have switched it with this one here. We've switched the 10 and the x, which changes this problem dramatically. Because now, with those flipped, we still have the 12 squared, because 12 is the length of the tangent, and it is squared. But now the other length, the other side, would be the exterior length, which would be 10, times the entire length, which would be x plus 10. And because of that switch, we're not having an x times x anymore. Now we're multiplying those two numbers by 10. Any questions on how this is set up? Now at this point here, we can simplify some things. 12 squared would be 144. Here we can distribute the 10. Well, 10 times x would be plus 100. Our next step would be 2. Minus 100 from both sides. So 144 minus 100 would be 44. And then we would and that would be our answer. Any questions on any of this here so far before we look at the last problem of the day? Are we good with this here? Find the radius of the aquarium tank. So we're still using the properties that we were just using, this theorem here, that the tangent squared is equal to the exterior secant times the entire length of the secant. So our tangent length is what? Is 20. Our tangent length would be 20, and it would be squared for our overall equation. Because the tangent would be the point that intersects the circle only once and connects to the point outside. Now the exterior length for this tank would be 8 times the entire length, which would be what? 8 plus 2r. Because we do, inside the tank, we do have the radius, but since we have the actual diameter, we have the radius twice, because the diameter is equal to twice the radius. Any questions on how we got this set up, or how we're going about solving this here? Well, 20 squared is what? Well, this one here is actually, you can do this one in your head. It's actually not that bad, because what's 2 squared? 4, and we multiply it, so 20 times 20, how many zeros do I have? 2 of them. So 20 squared is 400. Luckily, with most of these 10, 20, 30, 40, 50, 60, it works the exact same way. Because we're just multiplying that first number and then 10 squared, which gives us 100. Here we can distribute the 8. Well, 8 times 8 is 64. 8 times 2r would be plus 16r. We can minus 64 from both sides, yes. So we do get 16r by itself. 6, 336. And we would get our answer. But are there any questions on how we got to this point here? Okay. Well, we would divide both sides by 16. 21. So the radius for this here is 21. And that's it. Any questions on any of this here? Any questions on anything we've done so far? Are we good with these here? Now, for the most part, these theories about circles seem very not relevant to anything, but they're actually quite handy, and have actually been quite handy in years past. Now, if we were asked, or kind of, it's easy to find out now, the diameter of the Earth, especially using modern technology, is actually quite not that hard to find. Y'all would agree with that? Because we can use technology and GPS to actually figure out the circumference of the Earth and figure it out. Now, the first actual civilization to figure out the circumference of the Earth was the Greeks. The Greeks actually figured it out. And depending on the estimation of their actual measurement unit, which I think is called a wheel, or their overall length, is not actually well known. It's not accurately recorded of what the actual length is. So depending on estimations, they were about somewhere between, I think it was like 7% to 20% off, 10%, 20% off of the actual overall circumference of the Earth. Even though they didn't have most engineering. Now, what they were able to do is they would take the sun, and using the sun, especially with it being directly overhead, they were actually able to find out what the angle over here was, and we could use the properties, especially the property circle we've been going over, to find the actual diameter of the Earth, or diameter of the circumference of the Earth, using these angles and formulas that we've been going over. So it's kind of an interesting thing, especially for a civilization that wasn't as advanced as ours, could create some of this stuff here. And if you actually delve into it, I know Miss Wilson's class, when they talk about Egyptian sconces, especially a lot of the columns, the intricacies that they actually have are actually incredible. I don't know if y'all have heard of, let's see here if I can write, phi, the golden ratio. And it's pretty much, this here is shown up in a lot of their building and architecture, that they could actually build it in this actual ratio. And I don't have the book here, but it's an actual corresponding length that increases as, as it goes out in accordance to these numbers here, and it increases along the overall scale. But